Yes, the National Electrical Code, or NEC, does require ground fault interrupter, or GFI, protection for bathroom heaters in many situations. GFI are crucial safety devices that protect against electrical shock. They work by monitoring the current flow into and from an appliance. If there's a difference, indicating a leakage of current, the GFI quickly cuts off the power. This is especially important in bathrooms because of the presence of water, which increases the risk of electric shock. The specific requirements for GFI protection of bathroom heaters can be found in NEC section 424.105. This section generally requires GFI protection for electric space and radiant heating panels and heating cable systems. Given that many bathroom heaters are either electric space heaters or radiant heating panels, they fall under this requirement. It is important to consult the most recent version of the NEC and any applicable local amendments to ensure compliance, as code requirements can change. For example, the 2023 NEC section 424.105 states that electric space heating cables installed under floor covering shall be protected by a ground fault circuit interrupter, or GFCI. This requirement ensures that if there is a fault in the heating cable, the GFCI will trip, preventing a potential electric shock hazard. It is important to note that this requirement applies to heating cables installed under floor coverings, which is a common application for bathroom heaters designed to warm the floor. Further details can be found in NEC 424.44, which discusses installation of cables in concrete or poured masonry floors. The heating cable shall not exceed 33 watts per square foot, 0.3 square meter of heated area, and shall not be installed in closets or over walls or partitions that extend to the floor. The spacing between heating cables shall not be less than 1 inch on centers. Cables shall be secured in place by non-metallic frames or spreaders or other approved means. During installation and until covered with flooring, the heating cable shall be protected from physical damage by approved means. The floor shall be finished with brick, concrete, tile, wood, or other approved floor covering or coverings. When radiant heating panels are installed in a bathroom, they must also be GFI protected according to NEC 424.105. These panels are often mounted on walls or ceilings and radiate heat into the room. Because they are in close proximity to water sources, the NEC requires GFI protection to minimize the risk of electrical shock. Note that the rating of the GFI should be suitable for the circuit it protects, typically 15 amps or 20 amps for a standard bathroom circuit. It is also important to regularly test the GFI to ensure it is functioning correctly. This can be done by pressing the test button on the GFI receptacle. The GFI should trip, cutting off power to the circuit. If it doesn't, the GFI may be defective and needs to be replaced. Another crucial aspect is the location of the GFI receptacle. It should be readily accessible and installed in accordance with NEC requirements, typically within a certain distance of the sink or water source. The NEC specifies that receptacles in bathrooms must be GFI protected, which often includes the receptacle serving the bathroom heater. However, it is also acceptable to protect the entire circuit with a GFI circuit breaker in the electrical panel. This provides protection for all devices on that circuit, including the bathroom heater. When installing a bathroom heater with GFI protection, it is essential to follow the manufacturer's instructions and local electrical codes. Ensure that the heater is properly grounded and that all wiring connections are secure. It is also important to use the correct size wiring for the heater's current draw to prevent overheating and potential fire hazards. To further clarify the NEC requirements, let's consider a few specific scenarios. Firstly, if the bathroom heater is a portable unit that plugs into a standard receptacle, the receptacle itself must be GFI protected. This can be achieved by replacing the existing receptacle with a GFI receptacle or by installing a GFI circuit breaker in the electrical panel that serves the receptacle. Secondly, if the bathroom heater is a permanently installed unit that is hardwired into the electrical system, the circuit serving the heater must be GFI protected. This can be done by installing a GFI circuit breaker in the electrical panel. Thirdly, if the bathroom heater is part of a larger electrical system, such as a heated floor, the entire system must be GFI protected. This ensures that any fault in the system will be detected and the power will be cut off, preventing electrical shock. Now, let's discuss some of the potential problems that can occur if a bathroom heater is not GFI protected. One of the most significant risks is electrical shock. If there is a fault in the heater, such as a damaged heating element or a loose wire, current can leak to ground. If a person comes into contact with this current, they can receive a potentially lethal electric shock. This risk is particularly high in bathrooms due to the presence of water, which can conduct electricity. Another potential problem is fire. If there is a fault in the heater and the current is not interrupted, it can cause overheating and potentially a fire. This is especially true if the heater is located near flammable materials, such as towels or curtains. GFI protection helps to prevent fires by quickly cutting off power to the circuit in the event of a fault. In addition to the NEC requirements, many local jurisdictions have their own electrical codes that may be more stringent. It is essential to check with your local building department to ensure that you are in compliance with all applicable codes. They can provide guidance on the specific requirements for GFI protection of bathroom heaters in your area. They will also advise you on any necessary permits or inspections. The installation of GFI protection for bathroom heaters is a relatively simple and inexpensive way to improve electrical safety. It is a critical component of any bathroom electrical system and can help to prevent electrical shock and fire. If you are unsure about how to install GFI protection, it is always best to consult with a qualified electrician. They can assess your electrical system and recommend the best solution for your needs. They can also ensure that the installation is done correctly and in compliance with all applicable codes. Remember, electrical safety is paramount, especially in bathrooms where water and electricity can be a dangerous combination. Always follow the NEC requirements and local electrical codes to ensure that your bathroom electrical system is safe and reliable. Ground fault circuit interrupters, or GFCIs, are essential for electrical safety in bathrooms, particularly concerning devices like heaters. Understanding their operation and proper installation is crucial. A GFCI constantly monitors the current flowing in a circuit. It compares the outgoing current on the hot wire with the incoming current on the neutral wire. Under normal conditions, these currents should be equal. If a fault occurs, such as a short circuit or a ground fault, some of the current may leak to ground through an unintended path, like a person touching a live wire or a faulty appliance. This creates an imbalance between the outgoing and incoming currents. A GFCI is designed to detect even small imbalances in current, typically around 5 mA. When an imbalance is detected, the GFCI trips, quickly cutting off the power to the circuit. This happens very rapidly, usually within a fraction of a second, which is fast enough to prevent serious injury or death from electric shock. There are two main types of GFCIs commonly used in bathrooms: receptacle-type GFCIs and circuit breaker-type GFCIs. Receptacle-type GFCIs are installed in place of standard electrical outlets. They have a test button and a reset button on the front. The test button is used to periodically check if the GFCI is functioning correctly. Pressing the test button should cause the GFCI to trip, cutting off power to the receptacle. The reset button is used to restore power to the receptacle after the GFCI has tripped. Circuit breaker type GFCIs are installed in the electrical panel. They provide GFI protection for the entire circuit. They also have a test button to check their functionality. When a circuit breaker type GFCI trips, it cuts off power to the entire circuit, not just a single receptacle. When installing a GFCI, it is important to follow the manufacturer's instructions and the NEC requirements. Firstly, turn off the power to the circuit at the electrical panel. Secondly, remove the existing receptacle or circuit breaker. Thirdly, connect the wires to the GFCI according to the instructions. Typically, there are separate terminals for the hot wire, the neutral wire, and the ground wire. Make sure the connections are secure. Fourthly, install the GFCI into the electrical box or the electrical panel. Fifthly, turn the power back on and test the GFCI by pressing the test button. Sixthly, if the GFCI trips, reset it by pressing the reset button. If the GFCI does not trip when the test button is pressed, it may be defective and needs to be replaced. It is important to note that GFCIs do not protect against overloads or short circuits. They only protect against ground faults. Overloads and short circuits are typically protected by circuit breakers or fuses. A common misconception is that GFCIs are only needed near water sources. While it is true that GFCIs are particularly important in bathrooms and kitchens, where there is a higher risk of electric shock due to the presence of water, GFCIs can also provide valuable protection in other areas of the home, such as garages, basements, and outdoor locations. The NEC has specific requirements for GFCI protection in these areas as well. In addition to GFCIs, another important safety device is the arc fault circuit interrupter, or SI. SIs protect against fires caused by arc faults, which are dangerous electrical faults that can occur when wires are damaged or connections are loose. SIs detect the unique characteristics of arc faults and quickly cut off the power to the circuit, preventing a fire. The NEC requires SIs in many areas of the home, particularly in bedrooms, living rooms, and dining rooms. Some combination of SI or GFCI devices exist. Regular testing of GFCIs is essential to ensure they are functioning properly. The NEC recommends testing GFCIs at least once a month. To test a GFCI, simply press the test button. The GFCI should trip, cutting off power to the circuit. If the GFCI does not trip, it may be defective and needs to be replaced. If a GFCI trips frequently, it may indicate a problem with the circuit or an appliance connected to the circuit. In this case, it is important to investigate the cause of the tripping and correct the problem. It could be a faulty appliance, a loose wire, or a ground fault. If you are not comfortable troubleshooting electrical problems, it is best to consult with a qualified electrician. In summary, GFCIs are crucial safety devices that protect against electrical shock. They work by monitoring the current flowing in a circuit and quickly cutting off the power if a ground fault is detected. The NEC requires GFI protection in many areas of the home, particularly in bathrooms, kitchens, and outdoor locations. Regular testing of GFCIs is essential to ensure they are functioning properly. Remember, electrical safety is paramount. Always follow the NEC requirements and local electrical codes to ensure that your home electrical system is safe and reliable. Always consult a qualified electrician when doing electrical work.